Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to AWS Backup, a fully managed service that helps you centralize and automate data protection across AWS services and on-premises environments. We'll walk you through the key concepts, show you how to set up your first backup plan, and explain how AWS Backup fits into a broader data protection strategy. Let's get started. AWS Backup is a fully managed service that simplifies and centralizes data protection across AWS services and hybrid workloads. Instead of managing backups individually for each service, AWS Backup provides a unified control plane that brings consistency, automation, and visibility to the backup process. This makes it easier to ensure that critical data is protected, no matter where it resides. With centralized management and policy-driven automation, teams can define backup rules once and apply them across multiple services and accounts. It supports cross-region and cross-account backup, enabling greater resilience and disaster recovery preparedness. AWS Backup also integrates with AWS organizations, making it easier to manage backup at scale across large enterprise environments. Key integrations include support for Amazon EC2, EBS, RDS, DynamoDB, EFS, FSx, and on-premises applications through AWS Storage Gateway. This wide service scope ensures that a broad range of workloads can be protected using a single, consistent approach. For DevOps teams, cloud architects, database administrators, and compliance officers, AWS Backup streamlines operations by eliminating the need for manual scripts or third-party tools. It improves operational efficiency, ensures alignment with compliance requirements, and helps enforce organization-wide data protection standards. Unlike traditional backup systems, AWS Backup offers native integration with AWS services and removes the burden of infrastructure management. The cost model is straightforward. Pay only for the backup storage you use and for data transferred between regions, with no upfront costs or long-term commitments. Understanding the key building blocks of AWS Backup is essential for designing reliable and cost-effective data protection strategies. At the heart of the service is the backup plan, a policy-based definition of how and when to back up AWS resources. This plan includes settings like frequency, backup windows, and how long to retain each recovery point. Each backup plan is made up of one or more backup rules. These rules specify the actual backup schedule, the start and completion windows, and lifecycle settings, such as when to move backups to cold storage or when to delete them altogether. Together, backup plans and rules form the operational backbone of your data protection strategy. A recovery point is the result of these rules in action. It's a point-in-time snapshot of your resource that you can use to restore data if needed. These recovery points are securely stored in backup vaults. A backup vault is an encrypted storage container with its own access policies, allowing you to segment backups by environment, department, or sensitivity level. Resources are linked to backup plans through resource assignments, which can be configured individually or at scale using resource tags. This makes it easy to apply backup policies across hundreds or even thousands of resources in a consistent, automated way. For services that support it, continuous backup enables point-in-time recovery, allowing data to be restored to any moment within a defined retention window, especially valuable for critical databases and high-frequency workloads. To optimize costs, AWS Backup supports cold storage tiering, automatically transitioning older backups to a lower-cost storage tier after a set period. Combined with cross-region and cross-account backup capabilities, this framework ensures resilient, secure, and highly available data protection across your entire AWS footprint. When creating your first backup plan with AWS Backup, you're defining a set of policies that automate how data protection is handled for your cloud resources. At the core of the plan is the AWS resource selection. This is where you define which services, like EC2, EBS, RDS, or DynamoDB, will be included in the plan. You can assign these resources individually or use tags to dynamically group them, making it easy to scale and maintain consistency across your environment. Next, you'll define the schedule options for your backups. AWS Backup supports flexible scheduling using cron expressions, allowing you to configure hourly, daily, weekly, monthly, or even fully customized backup frequencies to align with your recovery objectives and business needs. To ensure minimal impact on application performance, you can define backup windows, specific timeframes during which backups are allowed to begin. This gives you control over when backup jobs run, helping avoid peak usage times or conflicting operations. Retention settings are used to determine how long each backup should be kept before it's automatically deleted. This could range from a few days to several years, depending on your compliance requirements and data lifecycle policies. Lifecycle management adds further automation by transitioning older backups to cold storage after a defined period, significantly reducing storage costs while maintaining access to historical recovery points. To support disaster recovery strategies, you can configure cross-region copy, which automatically replicates backups to a secondary AWS region. For centralized governance across large organizations, cross-account copy enables backups to be securely replicated to a separate AWS account. Finally, for services like RDS or DynamoDB that support it, continuous backup configuration allows for point-in-time recovery. This gives you the flexibility to restore data to any exact moment within your defined retention window, offering granular recovery in case of data loss or corruption. This illustration brings to life how AWS Backup serves as a centralized, fully managed solution for protecting a wide range of AWS services, spanning compute, storage, database, and business applications. At the center of this ecosystem is the Backup Vault, a secure, encrypted repository where all backup data is stored and organized. The journey begins with the backup administrator, who defines backup plans tailored to the organization's data protection strategy. These plans specify how often backups should be taken, how long they should be retained, and how they align with the organization's recovery point objectives, RPO, and recovery time objectives, RTO. Once configured, these policies are automatically enforced by AWS Backup, removing the need for manual backup scripting or custom scheduling logic. With the plans in place, AWS Backup steps in to orchestrate the backup process across supported services. Backups are securely written to the backup vault, and restore operations can be initiated whenever needed. This ensures that whether you're dealing with an Amazon EC2 instance, an RDS database, an EFS file system, or even VMware workloads on premises, your data is protected and recoverable. To reinforce security and operational control, AWS Backup integrates with CloudTrail for logging, CloudWatch for monitoring, and Amazon SNS for notifications. These services provide real-time visibility into backup jobs, generate alerts for failures or unusual activity, and help maintain a complete audit trail for compliance and troubleshooting. The illustration also shows how cross-account backup enables organizations to replicate backups to vaults and other AWS accounts. This adds an extra layer of protection, supports disaster recovery, and aligns with enterprise governance strategies by separating operational and recovery environments. Finally, AWS Backup supports compliance reporting, helping teams demonstrate that their backup practices meet both internal policies and external regulations. Whether you're subject to HIPAA, GDPR, or simply enforcing internal data protection standards, AWS Backup makes it easier to stay compliant with minimal overhead. AWS Backup offers broad support for many AWS services, making it easy to implement a unified data protection strategy across your cloud infrastructure. Starting with Amazon EC2, AWS Backup provides instance-level protection by capturing all attached EBS volumes within a single, consistent recovery point. This makes restoring a full instance seamless and efficient. For Amazon EBS, the service delivers volume-level snapshots with block-level incremental backups. This means only the changes since the last backup are stored, significantly reducing both backup duration and storage costs while ensuring data durability. Amazon RDS and Aurora are natively supported, allowing for automated snapshots along with transaction log capture. This enables point-in-time recovery so you can restore your database to a specific second within the retention period, a crucial capability for production database environments. Amazon DynamoDB backups have zero performance impact, allowing tables to be protected without affecting throughput or latency. With point-in-time recovery available for up to 35 days, you can recover to any moment, giving strong protection against logical errors or accidental writes. Amazon EFS and FSx file systems are fully supported as well, with backups that retain file system metadata and access controls. This ensures that when you restore, the structure and permissions of the data are preserved exactly as expected. For Amazon S3, AWS Backup supports both continuous and scheduled backups of entire buckets. This adds a vital layer of protection against accidental deletions, overwrites, or malicious changes. The service also extends beyond the cloud to protect on-premises VMware virtual machines, using AWS Storage Gateway integration to bring them under the same centralized management model. Finally, for workloads running SAP HANA on EC2, AWS Backup offers application-consistent backups. This ensures that critical enterprise databases can be recovered reliably, maintaining consistency across the application stack. When it comes to backing up databases on Amazon RDS, it's important to recognize that each database engine brings its own behaviors, capabilities, and constraints. For PostgreSQL, AWS Backup integrates with the native write-ahead logging WAL mechanism. By enabling WAL archiving, you can complement RDS snapshot backups with continuous log capture, allowing for granular point-in-time recovery while preserving transactional integrity. In MySQL-based databases, binary logs play a key role. These logs are essential for replication, but they're also critical for backup consistency. Managing the retention and purge settings of binary logs ensures that point-in-time recovery windows are preserved without unnecessarily consuming storage. With Oracle databases running on RDS, traditional tools like RMAN are partially supported. While RMAN's full flexibility isn't available due to the managed nature of RDS, certain RMAN-compatible commands can still be used for advanced recovery tasks, especially in combination with snapshot backups. SQL Server brings another layer of complexity. Its differential and log backups are managed behind the scenes by RDS. Understanding how these interact with automated snapshotting helps you anticipate recovery behavior and align it with business requirements. Compression ratios during backup can vary significantly across engines. PostgreSQL may compress differently from SQL Server or Oracle, and this affects both your storage footprint and cost efficiency. Transaction log handling differs as well. PostgreSQL's WAL, SQL Server's transaction logs, and MySQL's binary logs all influence how fine-grained your recovery can be and how long it takes to reach a consistent state post-restore. Understanding these engine-specific characteristics empowers you to design backup strategies that are not only compliant and cost-effective, but also tailored to the operational realities of your chosen database platform. As your backup strategy matures, AWS Backup offers powerful configuration options to support advanced protection, compliance, and cost optimization goals. One such feature is differential backup windows, which allow you to define different backup timeframes for various resource types. This lets you align backup operations with each workload's unique usage patterns, such as running database backups overnight and file system backups during off-peak hours. With multi-tier retention, you can create multiple backup copies with distinct retention schedules. For instance, you might retain daily backups for 1 week, weekly backups for a month, and monthly or yearly copies for archival or compliance purposes, all within the same backup plan. To support regulatory and legal obligations, legal hold implementation allows you to retain certain backups indefinitely. This ensures that critical recovery points are preserved until explicitly released, helping you meet legal or audit requirements without the risk of automatic deletion. Security-conscious organizations can implement air-gapped vault designs by creating isolated backup vaults with tightly restricted access. These vaults can serve as a last line of defense, storing critical backups separately from operational environments. For organizations with complex geographic or organizational needs, copy action chains let you define sequential backup copies across multiple regions and accounts. This defense-in-depth strategy enhances redundancy and recovery options in case of regional failures or compromised accounts. Service-specific parameters add another layer of customization, such as enabling transaction log backups for Amazon RDS to support fine-grained recovery. To ensure reliability, backup plan testing through regular test restorations is essential. This practice validates that your backup plans are not only configured correctly, but are also capable of full recovery when needed. AWS Backup doesn't operate in isolation. It integrates deeply with a broad range of AWS services, enabling automated, secure, and compliant data protection at scale. With AWS CloudFormation, you can define your entire backup environment as code. This includes backup plans, vaults, and resource assignments, allowing teams to deploy standardized backup configurations consistently across multiple accounts or environments, with version control and repeatability. For ongoing compliance, AWS Config plays a key role. By using custom AWS config rules, you can continuously evaluate whether resources are covered by appropriate backup plans and whether those plans are being applied and executed as expected. Through AWS organizations, AWS Backup supports centralized, organization-wide backup policies. You can apply backup plans across multiple accounts in a structured hierarchy, making it easier to enforce consistent protection policies, especially in large-scale or multi-team AWS environments. AWS Systems Manager helps operationalize your backup workflows. You can automate backup operations using Systems Manager runbooks or schedule backups through maintenance windows, ensuring your data protection aligns with operational tasks without additional manual effort. Integration with AWS Security Hub brings backup compliance into your centralized security and compliance posture. Backup-related findings can be aggregated alongside other security insights, offering a holistic view of your environment's risk and readiness. With Amazon CloudWatch, you gain deep visibility into backup activity. You can monitor backup metrics, track trends, set alarms, and build dashboards to understand performance, detect anomalies, or get alerted on failures in real time. Finally, AWS Identity and Access Management allows you to implement fine-grained access control over backup resources. You can define who can create, modify, or restore backups, ensuring the right level of protection while supporting strong security governance. Security and compliance are foundational pillars of AWS Backup, designed to help you meet both internal governance requirements and external regulatory obligations. All backups are encrypted end-to-end, both at rest and transit, using AWS Key Management Service. You can choose between AWS managed keys or bring your own customer managed keys, allowing full control over encryption lifecycle and permissions. Access to backup operations is governed by a strict access control framework using AWS Identity and Access Management. You can implement fine-grained IAM policies to enforce the principle of least privilege, ensuring that only authorized users can create, restore, or delete backups, and only for specific resources or backup vaults. To strengthen data immutability, Vault Lock functionality provides tamper-proof protection. Once configured, backup policies and stored recovery points cannot be altered or deleted until their defined retention period expires, protecting your backups against accidental deletion or malicious insider threats. AWS Backup operates under the shared responsibility model, where AWS secures the infrastructure and you are responsible for securing your data and backup configurations. This clear delineation ensures you know exactly where your responsibilities lie. For increased security and compliance, private network backups can be enabled via VPC endpoints, allowing backup data to flow entirely within your AWS network without traversing the public internet. This is particularly important for highly sensitive workloads in regulated industries. All backup operations, whether initiated manually or through policies, are logged through AWS CloudTrail, enabling detailed audit trail implementation. This visibility supports forensic investigations, operational audits, and real-time alerting. Lastly, AWS Backup is designed to help meet industry regulations. It supports compliance validation for standards like HIPAA, PCI DSS, GDPR, and many others, helping your organization maintain a strong and provable compliance posture across its backup and recovery processes. When it comes to pricing, AWS Backup is designed to be flexible, scalable, and aligned with actual usage, offering a cost-effective way to manage data protection across your AWS environment. At its core, AWS Backup follows a pay-as-you-go pricing model. That means there are no upfront commitments or long-term contracts. You only pay for what you use, based on the amount of backup data stored and the resources you restore. Charges for backup storage are calculated per gigabyte per month. This applies to backups stored in the standard storage tier, which is optimized for frequent access and faster restore times. To help reduce long-term storage costs, AWS Backup also supports a cold storage tier. Cold storage is ideal for backups that are rarely accessed and can cut costs by up to 75% compared to standard storage. When you need to restore a backup, you'll incur additional charges based on the amount of data restored. These restore costs vary by AWS service and may also include data transfer fees, especially if you're restoring across regions. Speaking of regions, AWS Backup supports cross-region backup copies. This is great for disaster recovery, but it does come with inter-region data transfer charges as the data is moved between AWS data centers. Similarly, if you're using cross-account backup, where backups are copied to a different AWS account for governance or security isolation, you'll incur the same data transfer and storage fees in the destination account. Another benefit of AWS Backup is resource-specific pricing. Services like Amazon RDS, DynamoDB, or EFS may have unique backup pricing models. It's important to review the AWS Backup pricing page to understand these differences based on the workloads you're protecting. For organizations using AWS Organizations, you can consolidate billing across accounts and even tag resources to track backup costs per team, department, or application. This makes it easier to manage budgets and enforce internal cost accountability. Managing backups at scale isn't just about protecting data. It's also about doing so efficiently. AWS Backup provides several tools and strategies to help you optimize costs without compromising on availability, compliance, or recovery speed. One of the most effective ways to reduce cost is through retention optimization. By aligning your retention policies with actual business and regulatory requirements, you avoid storing backups longer than necessary. This reduces your storage footprint and helps eliminate unnecessary spend over time. Backup cadence optimization is another powerful lever. By carefully tuning how often backups are taken, whether hourly, daily, or weekly, you can strike the right balance between recovery point objectives, RPOs, and cost. Frequent backups increase storage usage, so it's important to only back up as often as recovery needs demand. When supported by the service, incremental backups should be the default strategy. Rather than duplicating full datasets every time, incremental backups only capture changes since the last backup. This dramatically reduces storage consumption and cuts down on network transfer costs, especially for large volumes of data. Cost optimization also benefits from lifecycle automation. By setting policies to automatically delete expired backups, you ensure that data isn't retained beyond what's needed, further controlling storage growth and associated costs. Implementing resource tagging for cost allocation helps you track exactly where your backup spend is going. By applying tags that reflect business units, environments, or project names, you can generate detailed billing reports and ensure costs are attributed to the right stakeholders. And for organizations using multiple AWS accounts, consolidated billing analysis through AWS Organizations enables a bird's-eye view of backup spending across the entire organization. This lets you spot patterns, identify cost-saving opportunities, and optimize spend at scale. Visibility is essential when it comes to backup operations. AWS Backup provides comprehensive monitoring and reporting capabilities that allow you to track performance, ensure compliance, and manage costs with confidence. At the center of the user experience is the Backup Job Dashboard, available through the AWS Backup Console. This real-time interface gives you a clear view of all backup jobs, whether completed, in progress, or failed. You can quickly drill down into job status, resource types, and execution times, making it easier to stay on top of daily operations and spot issues before they escalate. For proactive monitoring, Amazon CloudWatch integration enables you to track a variety of key metrics related to your backups. You can visualize trends such as vault storage size or number of recovery points, and set up custom CloudWatch alarms that trigger when thresholds are breached. This lets you automate response actions or notify teams instantly. To complement this, AWS Backup includes a job notification framework. You can configure Amazon SNS topics to automatically send alerts when backup or restore jobs complete, or if they fail. These notifications can be integrated into operations channels like email, Slack, or ticketing systems, ensuring teams stay informed in real time. Ensuring adherence to internal and external requirements is easy with compliance reporting. You can generate reports that show whether resources are being backed up according to defined schedules, retention periods, and policy scopes. This supports internal audits and helps prove compliance with industry regulations. In addition, audit history is fully traceable through AWS CloudTrail. Every backup-related action, whether it's a policy update, a job trigger, or a restore, is logged and timestamped. This audit trail is essential for forensic analysis, compliance verification, and governance oversight. Finally, to monitor the financial side of your backup strategy, cost tracking is integrated via AWS Cost Explorer. With proper resource tagging, you can isolate and analyze backup-related expenses, attribute them to specific projects or departments, and identify opportunities for cost savings. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.